Vedic maths or Vedic mathematics is a collection of methods or sutras to solve numerical computations quickly and faster. It consists of 16 sutras called formulae and 13 sub-sutras called sub-formulae, which can be applied to the solving of problems in arithmetic, algebra, geometry, calculus, conics, etc. Vedic mathematics is a system of mathematics which was discovered by Indian mathematician Jagadguru Sri Bharati Krishna Tirthaji in the period between AD 1911 and 1918 and published his findings in a Vedic mathematics book by Tirthaji Maharaj using regular mathematical steps. Solving problems sometimes are complex and time-consuming. But using Vedic mathematics general techniques, applicable to all sets of given data, and specific techniques, applicable to specific sets of given data, numerical calculations can be done very fast. What are the benefits of learning Vedic mathematics? You can solve any difficult, time-consuming G problem or ICSE, CBSE math immediately using Vedic math tricks. Moreover, just by using Vedic math you can solve a problem mentally, and that's the beauty of Vedic maths. While you encounter polynomial functions and quadratic sums in a higher class in CBSE or ICSE board, knowledge of Vedic math will lend a helping hand to beat the difficulty level of those sums. Yavadunam Tavadunakritya Varga Yoja shortcut method in Vedic mathematics to square a number when it is closer to power of 10, 100 1,000ths. Commonly called as Yavadunam Sutra square its deficiency, i.e. whatever the extent of its deficiency, excess is, reduce, increase it still further to that extent and also square its deficiency, excess. Examples: 9 2 equals 9 to 1, 12 equals 8 over 1 equals 81. Here 9 is 1 less than 10, base 10, so deficiency equals 1, reduce it still further to that extent. So, 9 to 1, equals 8. Square its deficiency, so 12 equals 1. Final answer: 81, 132 equals 13 plus 3, 32 equals 16 ninths equals 169. Here 13 is 3 more than 10, base 10. So excess equals 3, increase it still further to that extent, so 13 plus 3 equals 16, square its excessive, so 3 2 equals 9. Final answer: 169, 182 equals 18 plus 8, 82 equals 26 64ths equals 32 quarters equals 324. Here 18 is 8 more than 10, base 10. So excess equals 8, increase it still further to that extent, so 18 plus 8 equals 26, square its excessive, so 8 2 equals 64. As we are using base 10, 6 gets carry forwarded to other side. Final answer: 324. You do. Find the soiree of 12, 14, 108, 97 ands 144, 196, 11,664, 9,409 similarly. Trick to square number using Yavadunam, which is closer to 100 1,000ths, base 100 1,000ths, is 932 equals 93 to 7, 72 equals 86 49ths equals 8,649, 892 equals 89 to 11, 112 equals 12,769, 10,022 equals 1,002 plus 2, 22 equals 1,004, 004 equals 1,004,004. Anurupya Sutra. If you the top row in a geometrical proportion, in the ratio of original digits themselves, you will find that the fourth figure on the right hand will be just the cube of second digit. Cube of numbers plays an important role in mathematics calculations, like in finding cube root of the numbers. So it is useful if we can do the cube of numbers quickly. We are trying for the same here using Anurupya Sutra of Vedic math. Let us learn how we can do it. Cubes of the single digits, i.e. from 1 to 9, are given below. 1 3 equals 1, 2 3 equals 8, 3 3 equals 27, 4 3 equals 64, 5 3 equals 125, 6 3 equals 216, 7 3 equals 300, 9 3 equals 729, 103 equals 1000. If we observe closely, the last digit of every cubic number is unique, i.e. numbers from 1 to 9. Does not repeat. This observation will be very helpful while calculating cube roots of any two-digit numbers. Let us first see the algebraic expression for cube root. A plus b, 3 equals a3 plus 3a2b plus 3ab2 plus b3. Above expression for cube root of a plus b contain 4 terms in total. First term is a 3, second term is a 2b equals a 3x, b, a, equals first term x, b, a. Third term is ab2 equals a 2bx, b, a, equals second term x, b, a. Fourth term is b3 equals ab2x, b, a, equals third term x, b, a. Here, b, a, is the common ratio also, as the whole. Second term is 3a2b equals a 2b plus 2a2b, split as sum of two terms, and third term is 3ab2 equals ab2 plus 2ab2, split as sum of two terms. So to find the cube, we have to compute a 3 and b, a. Following is the step-by-step description of finding the cube of two-digit number. Step 1. In the first row, start with a cubed as first term and multiplying first term by b, a, to get second term. Step 2. Repeat the multiplication till fourth term. Step 3. In the second row, double the two middle terms, i.e. second term and third term, and write just below second term and third term. Step 4. Add them vertically in columns. Carry forward the 10th place digit to next column. The example given below will describe this method well. Example. 113. Here a equals 1, b equals 1, a 3 equals 1, b, a equals 1 over 1 equals 1. Here common ratio is equal to 1. Now see the formation of the table. First row 1 1 1 1, second row 2 2, add 1, 3, 3, 1, 1 1 3 equals 1331. Example. 133. Here a equals 1, b equals 3, a 3 equals 1, b, a equals 3 over 1 equals 3. Here common ratio is greater than 1. Now see the formation of the table. First row 1, 3, 9, 2 7, note. Fourth term is just b3 as shown above in algebraic second row 6 18 expression. Add 1, 9, 2 7, 2 7, equals 1977. Apply carryover rule. 2 2 equals 19972 equals 11971 equals 2, 1, 9, 7, 133 equals 2197. Example. 523. b equals 2, a 3 equals 125, b, a equals 2/5. Here common ratio is less than 1. Now see the formation of the table. First row 1 2 5, 5 0, 2 of the table. First row 1, 3, 9, 2 7, note. Fourth term is just b3 as shown above in algebraic second row 6 18 expression. Add 1, 9, 2 7, 2 7, equals 1977. Apply carryover rule. 2 2 equals 19972 equals 11971 equals 2, 1, 9, 7, 133 equals 2197. Example 520. B equals 2, a 3 equals 125, B, A equals 2/5. Here common ratio is less than 1. Now see the formation of the table. First row 125, 50, 20, 8. Second row 140, add 125, 150, 60, 8, equals 125, 0, 0, 8. Apply carry. 15 6 equals 140, 6, 0, 8, 523 equals 140,608. Square root of perfect square number, if an exact square ends in 1. Its square root ends in 1 or 9, if an exact square ends in 4, its square root ends in 2 or 8, if an exact square ends in 5. Its square root ends in 5, if an exact square ends in 6, its square root ends in 4 or 6, if an exact square ends in 9. Its square root ends in 3 or 7. You do. Find the square root of 841, 1600, 4225 ands. 29, 40, 65 number. Square root 3969. Step 39, 69 grouping. From right to left 38 is greater than 36, the perfect square number of 62, and 69 is lesser than 64. Which is a perfect square number of 82, 3600, 6400, 602, 802. Therefore the given number lies between 3600 and 6400. That means their square number will be between and 80. So the first number in the square root will be 6. The number in the units places is 9, so the square number should be ending with 3 or 7. As discussed above, the square root of the given number should be either 63 or 67. Applying digit sum method to find the square root. 63 equals 3969, 6 plus 3 equals 3 plus 9 plus 6 plus 9. 9 equals 2 plus 7. 9 equals 9. So the square root of number 3969 is 63. Answer 3969 equals 63. Square root of imperfect square number. Number steps. Square root 2. The given number is not a perfect square. The nearest square number is 1 and 4. 1 plus 1/2. 1 plus 0.5. 1.5. Square root of 1 is 1. Add 1 divided by 1 plus 1, i.e. 1 divided by twice the perfect square number 1.5. The same when calculated in calculator gives 1.414, which is approximately equal to 1.5 square root 20 square root 2025. 5 equals 2025 is the perfect square of 5. Subtract it from 1/10, 1 divided by twice the perfect square 25. 5/10, 5. 0.54.5. The same when calculated in calculator gives 4.47, which is approximately equal to 4.5. Cube root of perfect cube number. The last digit of the cube root of an exact cube is obvious. 13 equals 1 greater than if the last digit of the perfect cube equals 1. The last digit of the cube root equals 123 equals 8 greater than if the last digit of the perfect cube equals 8. The last digit of the cube root equals 233 equals 27 greater than if the last digit of the perfect cube equals 7. The last digit of the cube root equals 343 equals 64 greater than if the last digit of the perfect cube equals 4. The last digit of the cube root equals 453 equals 125 greater than if the last digit of the perfect cube equals 5. The last digit of the cube root equals 563 equals 216 greater than if the last digit of the perfect cube equals 6. The last digit of the cube root equals 673 equals 343 greater than if the last digit of the perfect cube equals 3. The last digit of the cube root equals 783 equals 512 greater than if the last digit of the perfect cube equals 2. The last digit of the cube root equals 893 equals 729 greater than if the last digit of the perfect cube equals 9. The last digit of the cube root equals 9. Example 1. Find cube root of 13,824. Step 1. Identify the last 3 digits and make groups of 3 digits from right side. That is 13,824 can be written as 13,824. Step 2. Take the last group, which is 824. The last digit of 824 is 4. Remember point 3, if the last digit of the perfect cube equals 4. The last digit of the cube root equals 4, hence the rightmost digit of the cube root equals 4. Step 3. Take the next group, which is 13. From point 3, we see that 13 lies between 8 and 27, which are cubes of 2 and 3 respectively. So we will take the cube root of the smaller number, i.e. 8, which is 2. So 2 is the tens digit of the answer. We are done and the answer is 24. You do. Find the cube root of 39,304, 15,625, 97,226, 287,496 and 34, 25. Identify the last 3 digits and make groups of 3 digits from right side. That is 1728 can be written as 1728. Step 2. Take the last group, which is 728. The last digit of 728 is 8. Remember, if the last digit of the perfect cube equals 8, the last digit of the cube root equals 2, hence the rightmost digit of the cube root equals 2. Step 3. Take the next group, which is 1. We see that 1 lies between 1 and 8, which are cubes of 1 and 2 respectively. So we will take the cube root of the smaller number, i.e. 1, which is 1. So 1 is the tens digit of the answer. We are done and the answer is 12. Example 3. Find cube root of 185,193. Step 1. 185,193 can be written as 185,193. Step 2. Take the last group, which is 193. The last digit of 193 is 3. Remember point 3, if the last digit of the perfect cube equals 3. The last digit of the cube root equals 7, hence the rightmost digit of the cube root equals 7. Step 3. Take the next group, which is 185. From point 3, we see that 185 lies between 125 and 216, which are cubes of 5 and 6 respectively. So we will take the cube root of the smaller number, i.e. 125, which is 5. So 5 is the tens digit of the answer. So, the answer equals 57. Thanks for watching.